Today, I'll be talking about how we used FME to integrate GIS and Maximo for Parks Victoria. I'm Rob Shukroon, and I've been in the geospatial industry for about 20 years. I'm a senior consultant at Clarita Solutions. At Clarita, we help asset-intensive organizations achieve their strategies to improve asset performance and improve asset management maturity. We are unique because we bring location context to asset operations. My specialties at Clarita include Python scripting and anything GIS or FME related, including integrating GIS with asset management systems, which is what I'll be talking about today. I know you all like technical talks, but I've only got about 10 minutes to talk about our solution with Parks Victoria and how we used FME to bring GIS assets into Maximo and vice versa. So we'll keep it fairly high level today. Our client, Parks Victoria, manages around 100,000 assets spread across 4 million hectares. Only about 50,000 of those are so far recorded in the asset register. The remainder will be captured in the field using Collector or an asset editing web application, which we developed for them. As you can see here, they have over 200 different asset classifications, ranging from picnic tables, barbecues, and toilet blocks to lighthouses, shipwrecks, and walking trails. So quite a broad and disparate range of assets, each with their own unique set of specification attributes. So quite a challenge to represent in both GIS and Maximo. Throughout this presentation, I'll discuss how we took Parks Victoria's request to get accurate asset information to the right people at the right time and place to improve asset management performance. So why did Parks Victoria want to implement an asset management information system in the first place? They did so to comply with the Victorian government's asset management accountability framework. They needed to build a process and have operational maturity. To do this, we transitioned them away from ad hoc, bespoke applications and manual processes to record asset information and coordinate maintenance works. We created an IBM Maximo solution integrated with their existing and new Esri ArcGIS tools. There were a lot of objectives to this project, but today I'm going to focus specifically on asset integration between Maximo and GIS. Essentially, assets created or edited in GIS needed to be reflected in Maximo, and changes to assets in Maximo needed to be reflected in GIS. And the challenge was to achieve this in near real time. I'm going to assume everyone here is familiar with GIS, but some of you may not know what Maximo is. IBM Maximo Application Suite provides a comprehensive solution for physical asset management. This flexible solution provides a unified platform that delivers asset lifecycle, asset performance, and maintenance management from end to end across the enterprise. Maximo is a market-leading EAM solution and is used by the largest asset-intensive organizations in the world. It includes functions to manage assets, work, service contracts, inventory, and procurement. We integrated primarily with assets, but also created workflows to integrate work orders and service requests. The solution that we came up with was to create a two-way synchronization between GIS and Maximo. We created FME workflows that handle the integration. Changes from GIS to Maximo are handled by scheduled integrations using automations on FME server. Changes from Maximo to GIS trigger webhooks on FME server, which initiate workflows that write to the GIS. To illustrate how this works, let's have a look at a couple of scenarios. Changes occur in GIS in one of two ways, either through a desktop user in a web editing application or by a ranger in the field capturing new assets or updating existing assets in Collector. So imagine a park ranger in the field collecting various attributes for an asset such as material, condition, physical dimensions, or even adding a new photograph. These changes save to the database and update the last edited field on the record. If they're working offline because they have limited internet connection, their changes will synchronize when they come back online. The key to the integration is the editor tracking on the record, recording the last edited date. Every 5 minutes, FME server runs two workspaces. The first one determines if there are any new or changed assets based on last edited date versus last runtime. The second one determines if there are any new attachments based on last edited date. Both of these store the global ID and feature class of the asset in standalone tables. If any of the above are true, then we run a third workspace to actually send the data to Maximo. These also update the standalone tables to update the process status so they don't get sent again. Workspaces expire if they're in the queue for more than 5 minutes. They'll run again and keep trying to send the same information next time the workspace runs until the asset has been successfully sent to Maximo. We use 3 Maximo transformers that have been published on FME Hub. The Maximo Object Creator to create a new asset in Maximo, the Maximo Object Querier to query an existing asset and get its object URL, and the Maximo Object Updater to update an existing asset with new information. These are just custom transformers with a few HTTP callers that authenticate against Maximo. The updater and creator simply need a JSON file as payload. Attachments can also be added here as well. We created custom Java objects in Maximo, which were different to the ones in the downloaded transformers. We had to modify these transformers to reference the Java object representing the asset table and tables related to the asset. Here's a sample JSON template used to send updates. The creation and update templates are actually much longer than this, but this one sends location information to Maximo. When a change to an asset is done on the ArcGIS side, FME sends this JSON message to Maximo, the endpoint being the Maximo REST URL. Upon receiving the message, Maximo transforms it using Python code, updates the Java object related to that URL, and finally updates the underlying table in the database. Now imagine we're back in the office and a user is at their desk in the Maximo interface and they're adding additional information to the asset record that wasn't available in the field at the time of creation. This can be the cost of the asset or the life expectancy or even adding an attachment. Any change to an asset record in Maximo triggers, on save, an outbound message to a designated endpoint. Triggering is achieved using Java listeners since each table in the Maximo database is represented by an object in Java in the Maximo application. In our case, the endpoint is a URL representing a webhook in FME server. The webhook is a URL which corresponds to the appropriate FME workspace. This time, an XML payload is sent with the message and is read by the workspace. The XML is parsed and attributes are written to update the corresponding record in the GIS asset feature class. Attachments can be added to an asset in Maximo, which also trigger a separate webhook. Attachments are sent via XML and decoded in FME and inserted as blobs into the attachment table. We also implemented a queue in FME server to ensure that incoming and outgoing messages were being processed in the correct order. This can be added to the webhook URL. We've also set the queue parameter in the automations to ensure that outgoing messages don't overlap with incoming messages. Now we have a way to capture the assets in the field and in the office. Parks Victoria are also currently in the process of recording the remaining 50,000 assets, which they don't have in the asset register. In the office, users can see the current state of all their assets at a glance. We created this dashboard in ArcGIS portal, which shows the total number of assets, their status, condition, and safety assessment. Users can filter on their geographic work zones, which are polygons which divide the state, or they can filter assets for a particular park. I spoke about Clarita at the beginning. You can visit our website if you'd like to learn more about us. Thank you for your time. If you have any questions about what I presented here today, you can email them at team or myself at claritasolutions.com. Thank you.